In this question, it is given that let f takes the closed interval 0 to 3 to r be defined by fx is equal to minimum of x minus box x and 1 plus box x minus x, where box x is the greatest integer less than or equal to x. Let P denotes the set of points containing all x belonging to the closed interval 0 to 3 where f is discontinuous, and Q denotes the set of all x belonging to the open interval 0 to 3 where f is not differentiable. Then the sum of number of elements in P and Q is equal to, you have to fill in the blank. Before I proceed further, let me tell you this concept that box x is discontinuous at integral point, and second thing to be noted is at every integral point left hand derivative of this is infinity and right hand derivative of this is 0 at every integral point, and at non-integral point derivative of this is always 0. And keeping this result in mind, x minus box x, which can also be written as fractional part of x, again it is discontinuous at every integral point, hence non-differentiable at every integral point. And at every integral point left hand derivative of this is minus infinity and right hand derivative of this is 1. Again, agreed that it is difficult to remember all these concepts, but if you know the reason behind all these concepts, then it is not difficult to remember the concept. And for understanding the reason, you will have to see my video lecture of differentiability of JEE mains level. And next point to be remembered is fractional part of x is a periodic function with period 1. That is, I mean to say 0.3 or 1.3 or 2.3 all have same values. And now the given information implies that fx is equal to minimum of fractional part of x and 1 minus fractional part of x, because this is fractional part of x, and if I take minus common, the interior part will again become fractional part of x. And to redefine this function, I would like to take the help of graph. Graph of fractional part of x is this is the graph of fractional part of x. Obviously, the graph of y equal to minus of fractional part of x will become just the mirror image of this graph in x-axis. This is the graph of, that is the graph of this will become and to draw the graph of this, we will be taking this graph 1 unit upward. Hence the graph of y equal to 1 minus fractional part of x will become and so on. this will be 1. And to redefine this function, first I will have to draw the graph of this and this on the same coordinate axis. This is the graph of y equal to fractional part of x. And now I will draw the graph of y equal to 1 minus fractional part of x. As I told you here, graph of this will become and so on. Hence, I can easily conclude that the graph of fx equal to minimum of these two becomes starting here, going up to this height, and then starting here and going up to this point. Note that starting point at x equal to 0 will be this, and ending point will be this at 1, because at 1 this is giving the answer 0 and this is giving the answer 1. As always, I have to take the minimum of these two. Hence, the graph will be this. It is clear that there is no point of discontinuity. Note that at this point it is continuous, because at 1 this is giving 0 and this is giving 1, and therefore I will be taking this value for x equal to 1. And for differentiability, I have to take only the open interval 0 to 3. And in the open interval 0 to 3, the points of non-differentiability are this one, this one, this one, this one, this one. That is, there are points of non-differentiability. And just for knowledge, I am telling you that had he told the close interval 0 to 3 for discussing differentiability, even then there would be only 5 points of non-differentiability, because when we are dealing with the closed interval 0 to 3, then at 0 you'll just have to find the right hand derivative, and right hand derivative is clearly 1, because this angle is 45 degree. And at 0 will not find left hand derivative, because the function is defined for 0 or more than 0. For less than 0 the function is not defined, and because right hand derivative is a finite number, therefore I will say the function is differentiable at 0. Similarly, at 3 you will be finding only left hand derivative. Right hand derivative will not be found, because the function is not defined for x more than 3, because the given interval is only this. Means, had he told the points of differentiability to be discussed as close interval 0 to 3, even then I would say that there are only 5 points of non-differentiability. Hence, sum of the number of elements in P and Q is equal to 5, because P is empty set and Q has 5 elements. Agreed, I could do this question pure mathematically also, but I found that the graphical way is more simple, hence I have done this question graphically. Had I been doing this question mathematically, then I would use this concept also, that x minus box x is a periodic function with period 1. By using periodicity, the length of solution will become less.